Today in class, we worked on taking real-world scenarios and pulling the math equations out of them. And now we're going to look at taking real-world scenarios and pulling inequalities from them. You will notice that it's very, very similar to regular equations, except we just have a few trigger words that are going to make us say inequalities instead of just equations. So our topic for today is, so where do these inequalities come from? And our answer is real-world problems. Yay! Pause the video and take a second to write down this problem. Just like in the last video, our first step is always to identify our unknowns or our variables. What is the question really asking us? So we want to look into the problem and try to figure that out. So we know how much the bracelets and earrings cost, but we don't know how many she needs to sell in order to make at least $500, correct? So our variables are going to be the number of bracelets sold, and let's give that the variable B, and then the other variable is going to be the number of earrings. Sold. And we can give that the variable E. Okay, so now that that's done, our second step is to identify the two different relationships or issues that are happening. So since we have two variables, we know that there are going to be two equations or inequalities that we are going to have. So we can look into the problem, and it says that the bracelets cost $2 each and the earrings cost $3 each, and she needs to make at least $500, right? So that's talking about money. So we can put that together and write a equation or inequality. So if we have that bracelets cost $2 each, so bracelets are B, right? 2B, and our earrings cost $3, so 3E. So if we had one bracelet, we'd make $2, right? Because 2 times 1 is 2. If we had one pair of earrings, then we'd make $3, correct? And she needs to make at least $500. So the $500 is going to go here. So I want you to notice something that's different than the last video that we were talking about. So we've got some trigger words. At least. At least is a really big trigger word, okay? That, whenever you see at least, you know you're talking about an inequality, okay? So at least, you can ask yourself, so does that mean that she can make more than $500 or less than $500? So at least, so is like maybe $550 at least $500? Yes. So at least means more than, so greater than or equal to, right? Because she can make $500, but she just has to make more than or equal to, correct? So we're going to draw the more than or equal to because the alligator is chomping on the thing that's bigger, correct? Yes. So we've got one equation, and now we need our other equation. So we're going to take a look into the problem, and we already dealt with the cost, right? There's one thing that we're missing. She knows that she will need to sell more than 50 bracelets. Okay, so bracelets is B, correct? So we've got another equation, and we've got bracelets is going to be more than 50 of them, right? So more than, that's greater than, correct? Is that greater than or equal to? Can she make 50 bracelets and that is 50 more than 50? No. 50 is not more than 50. It is the same. So it's strictly greater than. It cannot be equal to. So those are our two equations right there. If you noticed, we had another trigger word, more than. So we have two trigger words so far, at least and more than. So let's go ahead and start a running list of these trigger words so that we can always go back to our notes and look if we're confused in a problem. So our inequality trigger words, at least, more than. That's what we have so far. Okay, so again, we are not going to actually solve this system of inequalities yet. We just want to practice how to write them from a given scenario. So keep this in your notes because we're going to come back to it and we're actually going to solve it later on in the week. But keep this in your notes. Don't do anything with it yet. Let's take a look at another example. Take a second and write this down in your notes. A yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35 and each class ring costs $140. How many yearbooks and class rings must the junior class buy to get their picnic? So again, step 1, we need to figure out our unknowns, identify what our variables are going to need to be. So we're talking about how many yearbooks and how many class rings, right? So those are going to be our variables. So let's take a look. So if we have yearbooks, we'll do y equals number of yearbooks. And class rings, yes. So we'll do C equals number of class rings. Okay, so we figured out our unknowns and our variables, and our step 2 is to look at the relationships in here. Identify the two different issues or topics that we're talking about. Okay, so we've got, we're talking about money in here, correct? So we have that each yearbook costs $35 and each class ring costs $140, and they need to spend at least $28,000, correct? So let's go ahead and take that and write it as our first equation. So we have that each yearbook costs $35, so we can write 35 times the number of yearbooks, correct? So 35 times y plus class rings cost $140. So we have $140 per class ring, 140C. And we have at least $28,000. So there we go again. We have the word at least. Okay, so does that mean that we can spend over $28,000? Yes, that is exactly what it means. We can spend over $28,000 or $28,000 and the junior class will still get a picnic. So that means we can spend over that much, right? So this side of our equation can be bigger than this side and it still work. Is greater than or equal to 28,000. Beautiful. So now we're going to take a look in the question for our second equation. Because since we have two variables, we need at least two equations, correct? So let's take a look in here. And I don't see anything that just jumps out to me. So when that's the case, we need to look at the context. Look at the context of the problem and ask yourself, okay, there's probably some hidden idea, right? And so I want to ask you guys, can you sell a negative number of items? Can I sell a negative amount of yearbooks? No. The answer is no. I cannot sell a negative number of yearbooks or a negative number of class rings. That just doesn't make any sense, right? So in order to write that down, we can create an equation that says I cannot have a negative number of anything, right? So our yearbooks cannot be negative. So our yearbooks cannot be negative. What does that mean? So that means that they have to be bigger than 0, correct? Greater than or equal to 0. Because anything less than 0 is a negative number, right? So y, our number of yearbooks, has to be greater than or equal to 0. Boom. And then we also know that our class rings cannot be 0 too, right? So let's pick another color. And our class rings must be greater than or equal to 0 also. So now we have a system of equations with 3 inequalities, right? And that's okay. We at least have at least 2 inequalities to make this work. We're not going to solve it yet. We're going to come back to this later. So I want you to keep this running list. The last problem had the same word at least in it, so we didn't add anything new. But I want you to keep a running list of the things that, of the inequality trigger words that we're going to find in problems. So our activity tomorrow in class is going to be looking at both systems of inequalities and systems of equations in real-world format. So we're going to keep adding to this list. If you can think of trigger words for inequalities right now, go ahead and keep writing, making a list, and we will check them tomorrow. And again, I want you to go back through your notes, read over the problems, read over the start to the solutions, and see if you have any questions or misunderstandings that we can talk about in class tomorrow. Come with questions. It helps me know where to go. Come with questions.